All right, thank you all for your patience. We are about to officially start. Good afternoon/morning. It is an honor to introduce DJ Davis, a seasoned IT professional whose career began on IBM mainframes and mid-range systems and expanded to encompass systems engineering, network design, and information security. DJ holds a bachelor's and a master's degree in business information systems and currently works in the Washington, D.C. area, helping others navigate complex IT ecosystems. With decades of experience and a passion for mentoring, DJ has made it his mission to reduce the intimidation factor that often surrounds Linux. His talk today, Let's Lose the Shock, Mystery of Linux, offers a pain-free introduction to Linux and compares his features to those of Microsoft Windows. If you ever felt hesitant to dive into the Linux world, this is your chance to change that. Please join me in welcoming DJ Davis. Awesome, welcome.
Hey, George. Thank you. Well, welcome. Thank you, everyone, for coming to the Blacks and Cyber sessions and presentations, and thanks for coming to DEF CON, because, you know, we have a lot of fun here. And hopefully we'll have a lot of fun today as we lose the shock value of Linux. Are y'all ready to have some fun? Yeah. All right. So let's get started into this. I'll tell you, well, we see the objectives that we have for this. So, you know, this is an overview awareness. We're not going to go into all commands and that kind of stuff. We're not going to be boring, but, you know, we're going to talk about the difference, you know, between Microsoft Windows and Linux and what have you, and look into a few of the features and things of this. So this is our game plan for today. We're not going to go heavy into comparing distributions. Let's say that all of the distributions are good. You know, you pick the one that you like, and then you pick another and another. Have a lot of fun with this. So we're going to have installing Linux in the appendix. You'll be able to go there and see that. And this slide deck will be on GitHub, so it's there for you. Maybe we'll see if we can hold the questions until the end of this. Just keep this moving. And my usual disclaimer is that this is not affiliated with work. You know, these are my ideas. However, you know, work is like fine, cool with me being here. You heard a little bit about my background. We're not going to spend much time with this, but, you know, just in different areas of computing, whatnot. And currently, you know, I work in IT security in that sector. Lots of fun there. My alma mater, VCU, go Rams. Pretty good school. So there are a lot of reasons to learn and to use Linux. So a lot of them are listed here. I'll just focus on a few toward the bottom of this. It's great for learning about, you know, how computers work and using different kinds of languages. You know, on a small machine, you can load a whole bunch of languages. I do. So it's a great operating system to see how, you know, the, you know, things work into detail. We'll have a little bit of detail here. It's good for hardware and software hacking. So pretty soon, if you're not doing that, you will be. Linux has a rich set of commands. I love some of the commands. I mentioned dd and grep. For no reason other than that, I think is a good reason to use Linux. And essentially, it's a very stable, reliable, and powerful OS that is like a free version of Unix. Unix, did I say? So what's special about Unix? Unix gets into, you know, why Linux is around. So Unix was the first portable, and that's an interesting word, portable operating system. And portable means to copy it from one place to somewhere else. So that was the first operating system that came out, and, you know, they were able to do that with. It's a modular design. That's pretty good for several reasons. And Unix started with interprocess communication. Microsoft uses this too, because if you've ever used a command prompt, you use that pipe thing. Yeah, Microsoft borrowed that from Unix at the time. You have input and output redirection. We see that less than, greater than sign, those types of things. And there are 3 files that are opened automatically for each process: standard in, standard out, and standard error. Okay, so this is a partial list of Linux distributions. You might see your favorite one on the list. Pick any of these or pick other ones. So, some differences between the commands of Linux and Microsoft. Yeah, the green Linux shows somewhat on this slide. But so basically, we have like the clear CLAR for clearing the screen versus the CLS. You grow up on that, you get used to that in Microsoft, the CLS. How we separate parts of a file. Linux uses the /, Microsoft uses the \. Then there is that fun thing about null versus null. It's NUL on Microsoft, and it's dev or device null, NULL, for Linux. There are some other differences in these commands, as you'll see here. Just how you do different things. Some of the commands might be the same, but the operation might be a little different. For example, changing a directory CD, that can work a little bit differently in both of those. Linux does have a live distribution, and you can run that off of a USB. I don't think you can do that often with Microsoft, although they do have some type of third-party thing that you can get, buy, or what have you. One nice thing that Microsoft does have is the pause command. And on here we show how you would implement that in Linux. You use the read command and a few options. That's here on the slide, and these will be, available. So there are other differences in things, between the 2 operating systems, and as we see here, in Linux you tend to work more with the command line. You tend to work more with the GUI in Microsoft. Linux has a lot of free languages and things that are available. Not so much. Well, you do have some in Microsoft, so that support is getting a lot better. Scripting is a little bit different as well, because you generally script with Bash in Linux, but you can script with other things as well. Microsoft is going to be using the PowerShell or using the command prompt. Some other differences. The super user account in Linux is root. In Microsoft is administrator. Now in Microsoft you can change that. You cannot change that in Linux. I wouldn't recommend trying to do that. You'd have to change a lot of underlying stuff to change that. And we'll look at the general format of the commands. It's not too difficult to work with, but there's just some things to be aware of. So, where did Linux come from? We outlined this in the slide right here, and so it began in 1969. AT&T, Bell Labs, they wanted to come up with a new operating system. In that same year, coincidentally, Linus Torvalds was born, 1969. So in the late 1970s, AT&T decided to release Unix for universities and some commercial use. Before then, it was used only by AT&T. In 1987, not sure if you heard of this part, this gentleman named Andrew Tannenbaum wrote an operating system called Minix, and that kind of mimicked the operation of Unix, but he had that for educational purposes. In '87, he came out with this book here, Operating Systems, that had, some of the code in it. And this book was used by, universities and places like that. I happened to see this book at least a few years later after that. I was hanging out in the Philippines for a while, and I went in a bookstore, and they had a second printing of that. And it was, a nice book, and I purchased it. It's in my garage someplace. I looked for it. I can't find that book, but it's a nice book to have. So in '88, we have Linus Torvalds, who attends the University of Helsinki. He goes away for a little while and starts coming back. Well, anyway, Linus gets a copy of the book, the software, and he starts playing with it. He creates the Linux kernel. The other notable thing about the Linux kernel is that he changed the license of it to GNU project. That way, you'd be able to sell it and whatnot and use it more for commercial use. So that's basically how Linux came about, from Unix, and we had that book of, about the operating systems. So what is Linux? We're going to kind of talk about what it is, what it's not. We know that it's an operating system. Linux has a kernel, okay, and that kernel is the main thing that Linus Torvalds works on. There are other pieces of it as well. The system bootloader, it can be several different types of bootloaders, and they're pretty good bootloaders. Grub. One nice thing about the Linux bootloaders is that they're good at loading in Microsoft Windows as well, so dual boot, you would tend to put Linux on there first. So you have the command line interpreter. Most of us know about Bash. It could be any of these other ones we list, as we have the SH shell. KSH shell, I believe, is for people who do systems development more. They would like that. There is the Bourne shell. Here is why I mentioned all of these. I mentioned the Bourne shell. What does Bash stand for? Born Again Shell. So that's how we get Bash. You can have a graphics interface, the GUI. And then you have package managers. It can be typically one of two types of package managers. You have the Red Hat one where you have the RPM, the Yum, all of that stuff. Or it can be typically out of the Debian affair where you have the APT. So you tend to have one or the other. You have startup scripts. And I mentioned two here because it's going to be one of these two, the system V via NIT or the system D. The system D is, the newer one that you tend to see on most systems. So Linux, you have a file system, and I list ext3, which you probably won't see, ext4, and there are a number of other ones. That BTRFS is kind of new. Also, I decided to list FAT32, FAT64, because when you have things like these flash drives, you're kind of using that. And Linux has other utilities and things that are involved with it. So what the kernel is, what the kernel does, basically it is the central core of the machine. It allocates the memory, does CPU scheduling, the I/O, all of these things that we have here, and we list some of the kernel features, especially to allocate memory and to allocate the time of the CPU. Most of our computers now have multiple processors, so the kernel schedules that. And you can see, different processes are being used. Okay, what is not in the kernel, and I believe this is important, the command line interpreter is not in the kernel. The GUI is not in the kernel. Commands, utility programs, those are not in the kernel. User programs. Now, sometimes hardware drivers, file systems, and these other things might not be in the kernel. They might or they might not be, depending upon what they are. Some of them can be loadable and unloadable, and so those are not, written into the kernel per se. but the kernel can connect to them. So this is the current Linux kernel. It's out. They update this, pretty often. This version is out. I believe it was July 27. This latest version came out. So where do we find the version of the kernel? And that's going to be in the /boot directory. We're going to look more into the different directories and things in a little bit. If you're in Linux, you can see it by running the uname command, and there are different varieties of the command. You put one switch on it, the -R, you get that little name. The big switch -A, you get all of, where the kernel is. In terms of the source code of the kernel, we list where that is. You can go and take a look at it. Interesting thing about it, I believe it says is 98 point something% C code. And on GitHub, it lists what the other variants of it are. And by the way, it is very good, very well written C code. Every time I look at it, I'm envious. I'm like, I've never seen C look this good. But yeah, they do a very good job at writing that. Okay. So here's a little illustration that we have that talks about some of the things that are in the kernel, and we call this the syscall because system calls. So we see this directory path. And don't worry, you have a copy of the slides, but this directory path has some of the different files of the system calls, and I highlight where they are. It's a little tricky finding these because there is also a file called syscall.h, a header file, but the files are not really listed in there. And so I guess when you're compiling the kernel, it's winding through all of this stuff to find it. But so the UNISD, we have it for 64-bit and 32-bit. These are where we can find the different syscalls of the kernel. So take a look at a few of these in UNIST 32. I highlight two of them. One is the exit, and that's going to be syscall number 1. I highlight the write, syscall number 4. You see a few other ones too. You see the open and the close. You see the read in addition to the write. You're wondering, why is DJ mentioning this? Okay, let's go to the next slide. Okay. So strace is a nice utility that prints out where a program does its system calls. And basically, we run this by saying the program is an assembly language program, hello ASM. And all it does is basically print hello world. Most of us are familiar with that. The first thing that you generally do in a language is find out how you print something, hello world, and you do that. And so this is the strace of hello world. There is not a whole lot there, and it basically does 3 system calls. The first one to get in there and start running. The next one, we're going to do a write, and it tells the OS how much it's going to write, and we do an exit. So I bolded the system calls in red. When you see the assembly program over there, you see how we're moving things into a few registers, and we call a routine, and so that directly reflects what we see in the strace. Okay, so that's for a little assembly language program. Let's take a look at the one for the C program. And again, don't worry, not an eye exam. You have the slides from this. So we see a couple of things in here. We see that there are a whole bunch of system calls. One of the reasons why C, like other languages, has a standard library. That standard library does a lot of stuff. Now, don't worry about all the stuff that it does, because this program actually runs quite quickly, a couple of milliseconds, but it does all of these system calls to get things done. One thing that I will say about the standard library that is unique is that it does buffered I/O. Buffered I/O is very good. Here's why. I'll see if I can cursor up to this assembly program for a second. You see If we're writing this in assembly, and we're not going to be doing this often, but if we were doing this, we would do a little something and then we would do a system call. We might build something else, print it with a system call. System calls are relatively expensive because the computer has to do things and saving the state of where it is, transferring control to the operating system and all of that. Now, I mean, it does this, hundreds of thousands of times a second, but still it's a relatively slow process. But the C library does buffering, so it takes all of this stuff and puts it in memory and writes it out in one operation. So it's a lot more efficient to do that. So yeah, that standard library is good, but still we see how it's doing things like opening files and things like that. We mentioned standard in, standard out, and standard error. I think we said those files are automatically opened for you. And when we take a look at this, we actually see these numbers in here. When the standard library goes to open a file, it picks file number 3. Why file number 3? Because 0 is always standard in, 1 is always standard out, and 2 is always standard error. C knows that, and so it knows where to start picking its files. Anyway, so how to log in? We're not really going to talk about logging into Linux, but let's talk about the run levels, because the run levels are important for how we do log in, whether or not it is, a CLI, a text screen, or whether it's the GUI. And so there are different run levels, all the way from shutting down the computer to single user, multi-user GUI, and we see run level 6. You can tell the computer run level 6, and if you have like root privileges, you know what it's going to do? Reboot, because that's what run level 6 is. It loads in those scripts. I say a little something about Ubuntu in here because they do several of the run levels. It's going to be like 5, no matter which one you pick. Several of them in Debian Ubuntu is going to be like, going into the GUI. So what's available in the GUI? Here is a list of the different programs. A lot of the stuff that we would see on a Windows system is there. Different names of the program because different people write that, but they're all free. Using the terminal when you go into the CLI, these are just some of the commands that you would try, and I'll mention a little something about each one of these. So the date command, it's going to tell you the date. In Windows, you have the date command to give you the date, the time command to give you the time of day. That's not exactly the same way it is in Linux. The date command will give you the time and date, because the time command will actually time how long it takes a program to run, how much time it spends in system space, how much time it spends in user space. So, if you type in time on a Linux system, don't worry, it's just going to come back and say you didn't put in a program or whatnot. Uptime tells you how long the computer has been running. It's a lot easier to find that in Linux than it is to find it in Windows. Sometimes you have to look on a Windows system and try different things to figure out how long has the server been up. Okay. There are other commands, say, we have the who command, you put different options on it. And by the way, the options, we call those, we might say -A. We might want to say like -A, but Linux, Unix people, they generally say minus or whatnot. That's okay. Using the terminal, you can, string commands together, put in that semicolon, that's a separator, okay? PS for processes. It's funny how people in Unix just abbreviated stuff. It's like they don't like to type. They tend to type very fast, but they have shorthand commands, and it's all typically in lowercase. Case matters totally in Linux. I know, the case can be annoying. But yeah, it matters. And so you make sure that you get that exactly correct. Other things for using the terminal, Linux has its own help system, and we call those the man pages. Man is short for what? Manual. So the man pages, just about every command has an entry in it. You might find a few things that don't. It's kind of funny. At that point, you just go Google. Whoever designed the package for whatever reason didn't create a man page. DF, just free, and you can give it different options. I like the -H option on DF because it gives you what stands for human readable. So it'll give you the file sizes in KB, MB, and those types of things, just whatever is usable at that point for the size of it. Okay. So this is how the file system is laid out. We mentioned /, and that's root. A few directories hang off of root, and we list them here. For example, the boot. Remember we were saying when you boot up the system, the kernel and stuff that's in the /boot directory. Then we have /etc, or we might call it etc, etc. Often we call it etc. And you have a number of system configuration files. Not all of them, but a lot of them there. /home is where you put the home directories, generally one for each user. /root, the root user has its own separate directory, separate from home. Now, why would we want to do that? Maybe the users might fill up the partition that has the home directories. Well, you want the root user to still be able to do their thing. So they're going to be in a different space. They can be in a different space in the file system. So we see a number of the different ones that we have. We have USR. We call it user bin. But we see that user, some people say, well, that's where you put user files. No, that's not exactly what it means. It comes from a specific term from the Unix system. But in any event, that is where you have the non-changeable files. Your programs and things like that will sit someplace. User bin for binary. User sbin for super user binary, programs that perhaps only the root user might use will be sitting there. You have user lib for your programs and things like that. And you can have links to these. For example, bin is actually a symbolic link pointing to user bin. So that kind of helps to make the system more flexible. So we have var, which is like variable length files and things. Your logs and things might go into var. That /proc is a very interesting directory because it's not actually a file system on disk. It is something that's simulated, and what it is it takes memory parameters and it puts it like it's a disk file so you can read them and write them. But those are lots of parameters dealing with the memory and the processes that are running on the computer. The last one we list here is the sys one, and that has parameters generally that you can read and set, and you will change the operation of the kernel. So you can update the parameters of the machine while it's still running. Okay. Here we look at moving around the file system, and these are just commands to know, pwd, print working directory, still like on Microsoft. They can work a little bit different. You can list files, ls stands for list, cd for change directory. If it's a hidden file, we're going to have a dot in front of it. So a dot in front of a file name means that it's hidden. How do we see that? Use the list command ls -a, you will see those files as well. I mentioned the dot and the dot dot. Now, Microsoft does this as well. And the dot is helpful for when you're moving around. That just means the directory where I am. Dot dot is the parent directory. Say, for example, you're someplace, you're in home, my directory, and you want to move up to the home. You just say change directory cd dot dot. And it moves up. And that is the same as for Microsoft in a lot of cases. So there are some other things that we use, and we'll see a little bit about this in a little while. For example, changing the permissions of the file. They call it change mode in Linux. Well, that's an interesting one. Change owner, you can change who owns the file. The stat command is nice because it gives you a lot of attributes on the file, the dates, the date when it was created, the date that it was updated, and lots of those. And other things about, the file pointers and things. Okay, let's talk a moment about the file permissions. And this is not necessarily difficult, and I believe that it can be easier than it is for Windows. So we see a directory, and in this case, we have some notable people. There are some very good inventors who have given us a lot of good stuff. But we see the RW, and that's for read, write. That third position, we call it execute. And that repeats read, write, execute, read, write, execute. Why do we have that 3 times? The middle of the slide kind of tells us that it's going to be for that user who owns that file, the group that the file belongs to. Is always going to belong to a group. Even if it's the name of the owner, it's going to have a group. And other. Other is everybody else in the world who's using the system. So you can have privileges for that or not. Below that, I give you a little matrix of how that works out. We come up with a number. So if it is a read, we have number 4. If it is a write, number 2. And if it's execute, it's 1. So if they have read, write, execute, it's going to be 4 plus 2 plus 1. Now you can change the permissions of the file by using 3 numbers, and that will represent all of those, whether it'll be anywhere from a 0 to a 7 for the user, a 0 to 7 for the group, and a 0 to 7 for the owner. You can change all of that. There are other ways that you can do it as well, and I didn't list those, but it's like you can change, a U, a plus this, a plus G, a minus that. I think it's a lot easier just, knowing the numbers and doing that. So this is something that, you'll play with, get on there and look at the files and things. And if you haven't done it, I think you'll find it's not that difficult to do. Now, so what are the effects of this? On this slide, we tell you what is affected for changing in a file if you change the read. And that's pretty obvious, I think. If they have that permission, that person can read the file. They don't have it, they can't read the file. And the same thing for write, and that execute means if it is a program or a script, whether or not they can run it. If it's not a script or a program, forget about the execute. So directories have these permissions too, and they have slightly similar nuanced meanings for a directory, but we list this here as well. Whether you can read a file that's in the directory. Write is whether you can write to it or delete the file, because in any event, you're writing to something in order to delete. And execute means, can I even get in there? So by changing these, you can set up a lot of who can get in and see what and do what and what have you. Now that root user, super user, can get to all sorts of stuff. So we talked about that proc directory. Proc is interesting, proc is fun. First thing about proc, and I did not list here, but for every process that's running, it's going to have a PID, a process ID, a number. And there is going to be a number there for that process. If you were to go into that directory of that number, you can see lots of parameters about that process. Now there are some other things, a lot of things as we list here that are simply files that you can list in and see some things that are going on. So what are some of these things? I'll list a few of them. Now, my favorite one is the second one, CPU info. And that is where you can get detailed information on all of the CPUs. Um, you can see the strings of the CPU that tells all of their options. Typically, everything is now 64-bit, but it wasn't, and there are some flags in there that will indicate that it's 64-bit. About the type of processes and things that it has. Another thing that is interesting about the CPU info, when you take a look at it, here's going to be kind of odd. You're going to see multiple CPUs because every computer nowadays has multiple CPUs. You're going to see the frequency of the CPU, how fast that thing is running. Let's say you have 8 CPUs. Here is what you're not going to see. You're not going to see all of them listing the same exact frequency. The frequencies of the microprocessors vary a bit, and they're going to have different numbers. But anyway, you'll see all of this on CPU info. When you run commands and things that show you, what the CPU is doing, it's pulling it from this file that's in this directory. The same thing for the other ones, mem info. All of that gets written to that file as if it is a, file on the operating system, but it's not. It's a pretty instantaneous spot where you can read and write and whatnot and get all the different versions. One thing that we're going to say about Linux, and we'll say it a couple of times, is that on a Linux system, everything is a file, but we'll get to that a little bit more in a moment. Okay. So command line editing, here's the stuff that you'll be using. You're probably used to a lot of this. Control C to end the program. You can up arrow, down arrow, go back and the previous commands. I forget if Microsoft does this. Control S and Control Q. Let's say you have a listing that's scrolling, Control Q, Control S, make it stop, go. We used to do that on terminals, way back in the day. Control D is interesting because if you're typing input into a program, say you're building a file from the command line, I want to put maybe 3 or 4 lines in this. How do you tell it that you're done with the input? Control D. Control Z will suspend a program that's running, and you can go back and resume the program. And you can take programs and you can put it in the foreground, and the background. Something that I list in here that's a little interesting just to know in working on Linux, we're used to Control C, Control V, copy, paste. When you're in the CLI, a lot of times you have to do Shift Control C, Shift Control V. That's just a little something you get used to. Okay, so we mentioned the 3 files that are associated with every running process, the standard in, standard out, standard error, and we see that there are 0, 1, and 2, the file numbers. They're always going to be that. So the input by default is going to be from the keyboard, the output by default, the user screen, standard error by default, the user screen, okay? Remember we said in Linux, everything is considered to be a file. Now, that standard input and output can be redirected to other places. You can send standard output to a file. In other words, you get the output just right at the disk somewhere. Or you can send it into another program. You can pipe it into another program. And that becomes its standard in to another program. So everything is a file in Linux. So what about Windows? Windows does not treat this the same. Windows tends to have APIs, application programming interfaces, and I mentioned PowerShell applets. When you use PowerShell, and PowerShell is good to use because, in addition to Linux, will be working with Windows. You will see that, as I joke, there are billions of them, but that is, just a fundamentally different way of doing things between the 2 operating systems. So I mentioned that, I list here that many operations and things can be done by open, reading, and closing a file. And I was mentioning the proc file system is a good example for doing all of that. a little bit more on using the terminal because we talked about redirecting stuff. You see that greater than redirecting, output. You can say, okay, send it into my output into a file. I'm listing a directory, send it to a file. I want to keep that output. You'll see the double arrow, and the difference between that is the single arrow will write the file. If something is there, it will overlay it, erase it, and start writing anew. The double arrow, it will append to the file. That's the only difference between the two. The less than sign is you can redirect the input. So on the slide, we list a few examples of that. So, and we see we have the pipe command, and we have the ampersand, which is used to put something in the background. And this is where it's good to look at these examples right here, because the first one, we see that we run a listing, and we redirect that to a file. In terms of redirecting the input, the sort is a very good command because by default, the sort command will look to the standard input for something. Typically, we're not going to be typing in that. We can, but typically we're not. It's going to be a file. So we redirect the input to a file, and we can redirect the output because if we don't, sort is just going to list it on the screen. But, so that's a very good example of doing that. I apologize for the next one where the find is in uppercase. That uppercase F is not going to work. That is what happens when you use PowerPoint. It wants to change each one of those. But we give an example of the 2-in-1 operator. And the thing about the 2-in-1 is that, so I mentioned standard out, which is file handle 1, and standard error, which is file handle 2. And those are two different things. And even if they're both going to the screen, they can be separate things, or a program might by default send those someplace else. But even if it does, we can combine those into one listing. A lot of times we don't want to, but if we need to, we can do that. So we see a few examples of using that pipe command, and we use pipe on Windows as well, but you can take output and redirect it to another program and do things. What we're doing in the two examples here is counting something. When we say who, it's going to give you a list of the people who are logged into the system. In this case, we want to know how many. So we pipe that into WC, which is word count, and we say -L. Give us the lines, not the characters, not all of that, because word count will give you different numbers. But so -L will give you just the lines. The same thing if I want to know how many files are on a disk. Not on a disk, in a directory. We will list it, use the -L so we get one thing for each file, and send that to word count. We'll get the number of files. So there are lots of things that we will use that for. Now that ampersand, and this is a good example of it, putting something in background. I like to use gedit, the graphical editor on Linux. Now, if I'm on a command line, and if I say, gedit, hello, whatever the file is, and just do that, the problem is it's going to hang the command line until that command finishes. And if I remember, I will have the ampersand, and so it's going to start gedit and run that in the background, and so I get the prompt back in the command. So that's just a little example of something that you might want to run in the background and not tie up the screen. Many other times you will be using that. So what can be a command on Linux? Lots of things. A program can be compiled. It can be an interpreter, say Python, or many other things. You can even run JavaScript. So things can be a script. And they can all look the same and run just like it's, command. So the command can be a file that is on the disk. It can also be built into the shell. We call the shell the command line interpreter. So it can be built in there. And we give you an indication of looking at, say, man built-ins, and you will see the commands that are built into the shell. For example, if you type ls for list, cd, those are not programs sitting on a disk. They are built into the shell, but they all run as commands. So the commands are generally available system-wide, and they can be in any directory, okay? Now, you can restrict some of them. For example, the privileged commands, some people might not be able to run those. And so, and one of several ways they can be restricted from everybody running them, okay? If you try to do something on a Linux system and the command is not there, if you're on the internet, oftentimes it'll tell you, well, this is in such and such a package, install this package and you'll get the command. So that's pretty helpful. And if you are the root user, running as root, and you put in something, command that's not there, say TCP dump or something, and it'll say that it's here, do you want me to install it? And you'll say yes or no. So, Linux and available memory. Linux attempts to use all of the memory that's on the system. It tends to make, very good use of it. Slowly over time, it will allocate memory to buffers and to cache. Now, the buffers are part of the virtual memory system. If you start paging, you will use some of the buffers, to move program segments and things. The cache is simply an area where files and things, that you've run files, and it will keep the contents of them in memory. If you run that file again, then it doesn't have to read the disk. It'll just read it from the blocks that are in memory. So what Linux does over time is it slowly takes the spare memory and starts allocating it to the cache and to the buffers. Now, this is still available memory. If you load a big program and you need it, it's going to deallocate that in a flash from wherever it put it, and it's available to your program. So it's not memory that is wasted or unavailable. It's instantly available. The adage in Linux, we should use all of the memory is a good thing. This is just a little example of the cache and the buffers over time. You'll see that they grow. Now, why am I mentioning this? Now, it might not matter as much today, and it still might matter in some cases, depending upon the way a Linux program looks at the free memory, what functions it used to read it. It might say that it's low on memory because it's not telling you about the memory that's in the cache and that's in the buffers. And what would happen a lot of times is that, you would have, servers and things running, and you see the memory usage is going up, past 85%, all the way up to 99%. And what happens at that point? People start screaming and running and all that type of thing. And you look at the machine and it's like, no, the machine is not running out of memory. It's just, it's just allocated as memory. And so when you say how much memory we have free, it's not telling you all of that. Now, the commands have changed where you can look at that and see that. In fact, you've been able to look at that and see that for a while. But the way that you can go in, with the program to look at that, there is a more modern way of doing it, and it's not a problem. But if a program uses the older way, then yeah, that can happen. And on the GitHub, there is a PDF that we have out there that talks about that, and the programming that looks at that. But when you see the memory going high, it's not necessarily a bad thing. Okay, so compatibility of the different files and things. So when we have the USB drives, and you use one by default, and what I list here is something sometimes this, catches me. And so it's like, I want to back up something and I'm moving it there. And as soon as it hits 4 gig, it stops. Well, that's because it's formatted as FAT32 and a file size is maximum 4 gigabytes. You can have lots of space on there, but you just stop there. And so it's a fairly easy fix for that. And that is to reformat that drive. You could do it on Windows. You format it as exFAT, and that's one of Microsoft's things. Linux will read it usually, and if Linux doesn't read it, you can install the packages so you can read it. But what that does is to allow you to use the very large USBs to store things on it. Also on this slide, we talk about the file systems of the different systems, the file types of the different systems. So in Windows, we have FAT32, NTFS, and exFAT. When we go to Mac and Linux, they cannot read NTFS. So they can read, the FAT, the exFAT. This slide gets back to some of the other things that we were saying earlier, in that Linux is a modular system, and we talk about some of the things that are modular in the Linux system. So all of these things can be changed out and set up differently. You can do that. Usually you're not going to do that on your own distribution, but you might. But you can roll your own distribution, and you will decide, which kernel version, which type of bootloader that you use. There are several of those. The package manager, we talked about that, whether it's going to be Red Hat, whether it's going to be Debian, but you can, select all of these things. So Linux and viruses, people say that Linux is more secure. It might be, and I think that's kind of a debatable type thing on it. But one thing that I do tell people is that a non-privileged user in Linux typically will not be able to write to as many system areas, as many programs and things. Unless an organization restricts their Windows computer, people can oftentimes, overlay stuff and whatnot. And, that's how malware can get attached to the system. But if it cannot write to a lot of the directories and things, that's that kind of cuts down on a lot of that. We mentioned su and sudo because when you install Linux, you do not necessarily have a root password that you put in there. Linux knows the root password, but it does not tell you that by default. You can get at it, but you're the first user who installed it, and you have rights to run that su and sudo. Su stands for switch user. So, and sudo means switch user, do something, and you can set up files and things, and we list all of that here, etc sudoers, that has, the people who can run various, privileged commands on the machine. I list a very fun and favorite command here, dd. It's questionable what dd actually stands for. I think some places like Wikipedia might say disk duplicator. That's not exactly sure where that comes from, but dd is very handy because you can copy anything with it. Everything is treated as a file. You can copy entire disk with it. You can back up disk with it. In the syntax that we have here, we see that we have a disk and we can back it up and we can compress it as we back it up. Compressing takes a bit longer, but you can take the contents of I have a computer here, I believe it's 256 gig SSD, and when I run DD on it and back it up and compress it, I think it's about 15% of the size. So it's a pretty handy command for doing that. Of course, this works on Windows partitions. You know, you can back up something, load it, back it up, that type of thing. Okay, we're getting to the final stretch. So I list some things that are awkward in Linux, you know, awkward or buggy. One thing that I will highlight Fedora, because you may get caught trying to upgrade and you want to make sure it doesn't get too far behind before you start upgrading. So, you know, we just, you know, highlight that. So in summary, you know, we've listed, you know, how Linux got its start, and it came from Minix. And, you know, you see some of the differences and things between Linux and the Windows systems. Okay. Are there any questions? Okay, so here is where you can find these slides and other information on GitHub for installing Linux, backing it up, and doing things so you can roll your own installations of that. And this information is available right now. So otherwise, I appreciate your time. Thanks.